Hello, illustrious elucidation chemistry graduate. Let's go. The final stop before Kingdom of Science come back home to Japan is Indonesia. Indonesia? Indonesia? Wow, mantap bro, ini yang gua tunggu-tunggu. They landed in Borneo or Kalimantan, and besides getting the same natural rubber they got in South America but in larger quantity, they got something else, a souvenir that will motivate people in Japan. Welcome to the rice field, motherfucker! By using fertilizer, mechanized farming, and planting 3 times a year, now Kingdom of Science got plenty of rice. Not to mention the rice is indica strain, which is bursting with amylopectin, so it resembles Japanese rice. Perfect gift for the Kingdom of Science members that stayed in Japan. This video I want to talk about the fertilizer and the amylopectin. Before arriving in Australia, Yo and Ukyo's ship stopped at Nauru to pick up some rocks called phosphorite. Phosphorite, together with nitric acid and wood ash, makes the super fertilizer. The exact chemical formula for phosphorite is not very important here. The important thing here is that the phosphorite contains phosphorus atom. Same with nitric acid representing nitrogen, and wood ash representing potassium. These 3 elements, NPK, are the one that's usually labeled in fertilizers, because they are very important nutrients to plants. N is used to form protein and DNA, which runs pretty much everything in plants. P, especially in phosphate form, is used again in DNA, and also the phospholipid that forms cell membrane, as well as the currency of energy in biology, ATP, meaning P is also everywhere in the plant. As for K, potassium ion in general provides ionic environment in plant cell necessary for metabolic process and thus acting as regulators. Protein synthesis needs K ions, and so does opening and closing stomata, the holes in leaves to get in CO2, maintaining cation-anion balance in plant cells, and so on. As for the sources of each element, for N, it's the air. 80% of air is N2, harbor process, osmotic process, yada yada. You should know this already. For P, it's true rocks, aka mining, like that phosphorite. For K though, it's also from mining, not from wood ash. From common sense alone, burning plants to make more plants is not going to be efficient nor sustainable. Am I right? These are the minerals mined, and they came from the ancient lake bottoms and sea bottoms that left behind minerals as they evaporate. On harvest, Senku said that the rice is indica strain and is bursting with amylopectin, and that means it resembles Japanese rice. What is amylopectin actually? Starch comes in 2 different kinds of molecules, the linear one called amylose and the branching one called amylopectin. Both are made using glucose with alpha-1,2,4 bonds. Amylopectin is more soluble in water and also forms gel in water. Glutinous rice in particular contains very little amylose and a lot of amylopectin, making it sticky. Japonica rice too has low amylose content and is sticky. However, indica rice is the opposite. It has higher amylose, so lower amylopectin, and less sticky and more dry and flaky. Does that mean what Senku said is wrong? If it's indica, then that's the opposite of Japanese rice. To sum up, the ingredients for the fertilizer shown in the manga represents the element NPK, and all the 3 elements are used everywhere in plants. N can be obtained from air, while P and K are obtained from mining. Amylopectin is a branch component of starch, is sticky, and found a lot in glutinous rice and Japonica rice, and much less in indica rice. That's all I have for now. I recommend this nitrogen compound focused episode, the nitric acid one in season 3 as your next video.